In this example, a bucket of water is lifted. Oh, you can just read it yourself. Read, read, read. Okay, well, what's the force in this case? The force is the weight of the bucket and the water that's in it at any given moment. And that force is going to be variable. When this process starts, when the bucket begins its journey upwards, the bucket weighs 4 pounds. There are 20 pounds of water in the bucket, so that's a total of 24 pounds. But as the bucket rises, as time goes by, the bucket rises. The water leaks out at the rate of 1/4 of a pound per second. Now, if I multiply that 1/4 of a pound per second by the number of seconds, let's call that t. T is time. Time is in seconds. This represents the weight of the water lost in t seconds. So what we have here clearly is a variable force, and I've expressed the force as a function of time, which isn't really what I want. I'd rather have it as a function of distance. And good news, remember the bucket of water is lifted vertically at a rate of 1.5 feet per second. X is distance, t is time, distance divided by time gives me my rate. It's 1.5, like I said, feet per second. Let's solve for t. Oh, by the way, let me do this. X over t is 3/2. Solve for t. You get t equals 2/3 times x. Plug that in here. Notice that t is in seconds, right? Seconds are going to cancel. This is going to end up being in pounds. My expression is going to change a little bit, though, because I'm replacing t by 2/3 times x. So this is minus 1/4 times 2/3 x. This is in pounds. This is in pounds. It reduces to 24 minus 1/6 x. And again, that's in pounds. What's nice is that I have my force as a function of distance rather than time. That's good. Because our work formula, if you look at the work formula, the general formula expresses work as the integral of force, where force is expressed in terms of distance, not time, not some other measurement. In this case, what are the limits of integration? Well, we're starting with x equals 0. Obviously, when we start, the weight of the bucket is 24. That occurs when x is 0. Weight of the bucket, I should say the bucket water system. The bucket plus the water in the beginning is a total of 24 pounds. That corresponds to x equals 0. And we raise the bucket 12 feet, so my upper limit of integration is going to be 12. The variable force is 24 minus 1/6 x. Incidentally, how much is the bucket water system going to weigh after the bucket's been raised 12 feet? And the answer is, and this has really nothing to do with the problem, we're not going to use this to do our calculation, but the weight of the bucket water system or water bucket system is 24 minus 12 times 1/6. 12 times 1/6 is 2. 24 minus 2 is 22. So once we raise it 12 feet, the total weight of the bucket and the water that's still in there will be 22 pounds. Anyways, I just thought I would throw that in. Don't know why. Use the fundamental theorem of calculus. 24x minus 1/6 times, you integrate x or antidifferentiate x, you get 1/2 x squared. Let's put brackets around there. Running from 0 to 12. Clean this up. This is 24x minus 1/12 x squared. When I evaluate this antiderivative 12, 24 times 12 is 288 minus 12 squared divided by 12. Well, that's just 12, isn't it? When I evaluate this antiderivative at 0, I get 0 minus 0, which is 0. So this is 276. And what are the work units? Well, force is measured in pounds and distance in feet, so this would be foot-pounds.